In today's lesson, we will be solving quadratics by factoring. And remember, this whole unit has been on polynomials. And a quadratic is just a specific type of polynomial. It just means that the polynomial has the highest exponent of 2. If you look at the bottom problem, we already have been solving quadratics in this form. So let's just quick review. Here we would first add 8 to both sides, which would leave us with 2x squared equals 8. And then we would divide both sides by 2, which would leave us with x squared equals 4. And then we would square root both sides, which would leave us that x equals 2 and x equals negative 2. Now, we can no longer use those steps to solve these types of quadratics that you're going to learn today, and that's because we have that middle term 6x. Anytime we have a middle term, we have to solve the quadratics a different way, and today we're going to solve by factoring. Before we begin solving quadratics by factoring, we have to understand one quick property, and that is the zero product property. It simply says that if you multiply two numbers together, and then if the result is then 0, then that means that either A had to be equal to 0 or B had to be equal to 0. Now, this also applies when you multiply two binomials together. If x plus 2 times x plus 3 equals 0, then that means either the first binomial x plus 2 equals 0, or the second binomial x plus 3 equals 0. And now, what we will be doing is trying to figure out what value of x allows this to be true. So, really just use inverse operations, subtract 2 on both sides, so x equals negative 2, and here subtract 3 on both sides, so x equals negative 3. Here are two examples in which we can use the zero product property to solve for x. So for the first one, 2x plus 5 times x minus 2 equals 0. So for that to be true, that means that either the first binomial 2x plus 5 has to be equal to 0, or the second binomial x minus 2 equals 0. And now we just have to solve for x on both cases, using inverse operations. So for the first one, subtract 5 on both sides, so 2x plus 5 equals 0, minus 5 and minus 5, which leaves us with 2x equals negative 5, and then divide both sides by 2, so x equals negative 5 halves. And then on the second one, we just have to add 2 to both sides, add 2 and add 2, so x equals positive 2. So there are two solutions for each of these. Same thing for the second example. You break your two binomials apart and set them both equal to 0. So 5x minus 3 equals 0, or x plus 4 equals 0. So we want to solve for both values of x that allow this to be true. On this left one, if we solve for x, we can add 3 to both sides. So 5x equals 3. And then divide both sides by 5, so x equals 3/5. Now on the right side, we just have to subtract 4 on both sides, so x equals negative 4. Those are my two solutions. Okay, we are now to the point where we can solve a quadratic by factoring. One quick note, before you can factor the trinomial, make sure that it is set equal to 0 before you start factoring. So, this first example, it's already set equal to 0, so you don't have to worry about that this time. But your first step is to simply factor that trinomial. So, if you remember, we have to find factors of 8 that add up to 6. So if you think about all the factors of 8, we have 1 times 8 and 2 times 4. And obviously it's 2 and 4 that add up to 6. So let's write this trinomial in factored form, where we have x plus 2 and x plus 4 equal to 0. So now we just want to know what values of x make this true. So now we can use the zero product property, break these two binomials up. If when you multiply them together you get 0, then that means that either the first binomial, x plus 2 equals 0, or the second binomial, x plus 4 equals 0. And now we just have to solve for x on both cases. So this left one, if you just subtract 2 on both sides, so x equals negative 2. And then on the other one, we can subtract 4 on both sides, so x equals negative 4. And those are my two solutions. For each one of these, you will have two different solutions. Let's do one more together, and then you can try two on your own. So here's an example where you have to keep this in mind. Before you can factor that trinomial, your equation has to be equal to 0. So what that means is we have to get this 48 to the other side. And anytime you move anything across that equal side, you do the opposite. So you want to think about subtracting 48 on both sides. So now we have the trinomial x squared minus 8x minus 48 equals 0. So now we have to factor it. We have to find factors of negative 48 that add up to negative 8. So let's list all the factors of negative 48. So negative 1 times 48, or the other way around, 1 times negative 48. Negative 2 times 24. Well, here are all the factors of negative 48. There's kind of a lot of them since there's negative, it always kind of doubles the options. So which one of these, when you add them together, gives you a negative 8? And that would be right here, 4 and negative 12. So let's write this trinomial in factored form. X and x, and it's equal to 0, and then just plug in our plus 4 and our minus 12. So now we have to continue solving what values of x allow this to be equal to 0. So let's see, if x plus 4 equals 0, then that means x would have to equal negative 4. It's really just the opposite. And if x minus 12 equals 0, then x would have to be equal to a positive 12. Same thing, it's the opposite of what's inside the binomial. So there you go, there are your two solutions. Here are two more examples. I would like you to write them down, pause the video, and try them, and then you can come back and check your answer. Here's how you solve the first one, and here's how you solve the second one. And if you notice, when we factor it, you get the same binomial twice, so you get the same solution twice. So this is a rare example where actually you only have one possible solution to solve that quadratic. There's the lesson. Good luck and have fun.